So this was what we call as magic, used to call as magic during our childhood days. Okay, where we used to take pieces of paper. Okay, used to take pieces of paper and rub the comb or a ruler, okay, over our head, and then used to tell our friends that, look, without touching the paper, I'm going to stick the paper to the ruler. Okay, and it was fun, yes, and that was magic. Okay, and still magic, it is still magic for us, because we do not know the phenomena behind that particular, okay, event that took place, okay, or a small experiment. So let me ruin your fun by saying that it is another type of force, okay, that was responsible for holding that particular piece of paper over that comb or a ruler. Okay, so that force is what we call as electromagnetic force. Okay, the force associated with the electric and the magnetic field is what we call as electromagnetic force. Okay, where the electric field is produced by a stationary charge and the magnetic field is produced by a moving charge. Okay, and this is carried by a particle called photon. Okay, a photon is a massless particle. Just like we talked about a hypothetical particle called graviton in gravitational force, in electromagnetic force, though this particle is not hypothetical, okay, because photon is everywhere. You are looking at the screen of your mobile phone right now, it is also because of photons. Okay, and that is also one of the electromagnetic interaction. Okay, so just like graviton, photon is also massless, okay, and propagates at the speed of light. So why do I have to know about electromagnetic force or electromagnetic interaction or electromagnetism? Okay, it is only and only because of electromagnetic interaction or electromagnetism that we are existing. How is it? It is because an atom, okay, this is a helium atom, and I'm just drawing this orbit in this way to make it clear that there are two electrons orbiting a nucleus consisting of two atoms and two neutrons. Okay, so in an atom we have a proton, a positively charged particle, we have a neutron that is a neutral particle, and an electron that is a negatively charged particle. Okay, we have these three particles that makes up a atom. Okay, so in this particular case, in an atom we have a positively charged particle at the nucleus. Okay, we have a positively charged particle at the nucleus which is solely responsible for attracting the electron around it. Okay, just like I showed to you just now, that the pieces of paper, gets attracted to the comb. Okay, and when I leave or when I give a little bit of push, when I shake that comb a little bit, then it falls down. Okay, so what is going on that particular case? It is because it is becoming neutral again and falls down. Okay, in the same way, atom is neutral. It is because it consists of a proton at the nucleus and an electron. Okay, where the proton attracts the electron to revolve around a particular orbit. Okay, and this particular electron interacts with other electrons. For example, this is one atom, okay, consisting of proton, neutron and electron, okay, having electron orbiting around it, okay, around the nucleus of this atom, and I have another atom. Okay, the same thing goes on out here. So this electron, the electron of this particular atom is going to interact with the electron of this particular atom. Okay, and then they are going to form a bond called electron bond. Okay, and this way they make up a molecule. So the electromagnetic interaction, the electromagnetic force is also responsible for the very existence of the visible matter. Okay, so the electromagnetic force is also similar to your gravitational force in case of range. Okay, just like gravity had a infinite range, the same is for the electromagnetic force. Okay, it has a infinite range. Okay, so consider this. These are my electrical charges. Okay, charges have their properties. Okay, and this is my magnet. Okay, we know there are two types of charges. One is positive charge and one is negative charge. Okay, one is positive charge and then one is negative charge. So when I bring two positive charges, okay, two positive charges close to each other, then they repel. Okay, two positive charges will repel each other. Okay, what we call as like charges repel each other. This is one of the properties of your electrical charges. And then we have one positive charge and another negative charge. So unlike charges attract each other. Okay, and then we have negative charge and negative charge again. That is the like charges. So like charges will repel each other. So let me come to your magnets. The properties are somewhat similar. Okay, in the case of electric charge and in case of magnets, the properties are somewhat similar except one. Okay, so we'll talk about that. When I bring poles, okay, suppose this is my north pole and this is my north pole. Okay, and when we have done this experiment in our childhood days, bringing two magnets, we feel that they are not getting attracted to each other and they repel. Okay, that is the like pole repel each other. The north pole will repel each other. Okay, and then we have unlike poles. Just like your unlike charges, we have unlike poles, that is north pole and south pole. That when we brought one magnet to another from the other side, okay, then suddenly we did not apply any force. Okay, it got stuck like this. This magnet got stuck to this magnet, okay, automatically at a particular distance. So unlike poles attract each other. Okay, and then we have south pole. Okay, like poles repel each other. So these are the similarities between the electric charge and the magnets. But one more thing that you have to know is that in the case of your electric, there exists a monopole, and in this case it is always dipole. Okay, in case of your electrical charges, an electrical charge can exist like the positive charge can exist on its own. It's like it's not compulsory for a negative charge to be present all the time with the electrical charge, with the positive charge, sorry. Unlike the case of electric charge, in case of magnets, we cannot have only north pole. There is always a south pole associated with this particular north pole. Okay, there's always a south pole associated with this particular north pole. So in case of your electrical charge, we do have monopoles, but in case of your magnets, we do not have monopoles. They always exist in dipoles. And this electric charge and magnets, okay, they exert a field. They have some kind of fields, what we call as electric fields and magnetic fields. Okay, in case of your electric fields, the electric field starts from the positive and goes to the negative in this way. Okay, and in case of your magnets, it starts from the north pole and goes to the south pole. Okay, it is somewhat similar. So if I have a positive and the positive, you know how it is going to look like, because in the positive charge, the electric field is on the outward direction. Okay, so when I have two positive fields, since both have the electric fields going in the outward direction, therefore they'll never attract each other. They'll always repel each other, because the fields are always on outward direction. Okay, same is the case with the magnets. Okay, same is the case with magnets. We have, if we bring two north pole together, okay, they have the electric field line, the magnetic field lines coming out. It's not going in. Whereas in the case of unlike charges or unlike poles, we have the negative. In the case of negative charge, it is going inward. In the case of positive charge, it is going outward. Therefore, okay, hence the attraction and hence the repulsion. For quite some time, it was thought that the electric force and the magnetic force are two different quantities, and there is no similarity or there is no connection in between these two forces. Okay, and then people went on doing more and more experiment in the field of electromagnetic theory, and they found that when we connect a solenoid, a coil, okay, over a source, okay, when we connect this, then they found that the change in current produces magnetic field. Okay, they found that some ferromagnetic substance, for example, let it be a nail, okay, starts sticking to this particular coil, and when they switched off this, then it is not sticking anymore, just like in the case of your bar magnets. Okay, this was what they found, that the change in current produces magnetic field. And then they thought that should it be true for the other way around? That is, can we produce current with the help of magnetic fields? Okay, we have already produced magnetic field with the help of current. Now can the reverse be possible? Then they found that when they made a magnet, okay, this is a moving magnet, okay, it is in motion. Okay, this magnet is in motion. So when they passed this particular magnet in and out of the solenoid, okay, in and out of this coil, okay, when I move the magnet, what happens is that at a particular level of your magnetic fields, okay, when I keep moving this, suppose this is my magnet, and when I keep moving this, then the magnetic field is changing. Okay, it is at one particular point, suppose this particular point, okay, this is a wire, when I push this magnet here, okay, then there is certain amount of magnetic field that is linked with this particular, okay, this particular conductor, okay, it is changing, okay, at this point it is something, at this point it is something, and when I move it, when I pull it, okay, and then it is changing again. So they found that the change in magnetic flux produces current. So both are interconnected. Okay, that is, the change in current produces magnetic field and the change in magnetic flux produces current. Then we have this particular phenomena called electromagnetic radiation, which refers to the waves of the electromagnetic fields. Okay, for example, your microwaves, radio waves, infrared, visible, X-rays, gamma rays, okay, and infrared. So this is what we call as electromagnetic radiation. Okay, and we have this electromagnetic wave. Okay, we have the electric field at one direction, and magnetic field at another direction. So according to your classical theory, okay, we have two fields in physics. One gives you the point of view of classical world, that is the macroscopic world, and we have another branch, that is the quantum, that gives you the visualization of physics in the quantum realm, which is like microscopic. Okay, so according to your classical theory, the electromagnetic waves is nothing but a synchronized oscillation of the electric field and the magnetic field. Okay, and this electric and the magnetic field are perpendicular to each other. Okay, these are perpendicular to each other, and also these are perpendicular to the direction of propagation. Okay, so this is your electromagnetic wave. Just like gravitational law put forward by Newton, okay, there is a law for electromagnetic force, or rather electrostatic force, because this particular formula governs the force between two particles at rest. So it is known as Coulomb's law, where he writes down F is equal to K Q1 Q2 divided by R square. Again, even electromagnetic force follows inverse square law, where K is the Coulomb's constant, Q1 is the charge in body 1, in this case it is a positive charge, Q2 is the charge in body 2, in this case it is the negative charge. And if I have to calculate the electromagnetic force between these two charges and compare it with the gravitational force, then I am going to find that the electrostatic force, okay, is always 40 times greater, approximately 40 times. It might vary by 1 digit or 2 digit, depending on whether it is a positive charge, positive negative charge, or negative charge. Okay, we are always going to find that the electrostatic force is more than the gravitational force. Okay, so moving to the properties of the electromagnetic force, the range is infinite, just like your gravitational force. The interacting particle, okay, the interacting particle that is mediating the interaction between these two charges or any charges is a photon. Okay, a photon is massless and propagates at the speed of light. The electromagnetic force interacts with all the charged particles. So this is your brief introduction of electromagnetic force.